Hi, this is Mr. Williamson, and today's video is about bonding of atoms. Before we get started, I'd like to remind you to make sure you take notes. It's important to get the information down. If you have any questions, make sure you see me in class, and I'll be glad to help you out. And also check the study guide and see what kind of questions are on the study guide that might help you prepare for the test. So let's get started. First of all, let's take a quick review. On the previous videos, we talked about the states of matter. States of matter, again, were a gas, liquid, and solid, and you should know about those. Atoms, and the parts of an atom, the protons, the electrons, and the neutrons. Ions that have lost or gained an electron, and isotopes, which have lost or gained a neutron. So if you don't know about those, make sure you go back and take a look at those on some of the earlier videos. First of all, let's talk about electron shells. Electron shells in an atom, on the earlier video, we talked about the protons and neutrons being inside the nucleus. Around the shell, the nucleus, is the orbitals. Now, they're not really circles, they're more like clouds. We talked about that in the video. But on the innermost orbital, there are 2 electrons, and that's all it can hold. And if it has 2, it's happy. On the next orbit, it can hold 8. Okay, and 8 would make it a full shell, and I like to refer to it as being a happy shell. It's a shell that has all of the electrons in it. It's full. If it's missing one of them, or if it has if it's missing a shell or missing an electron in that area, then I think of it as not being happy. And the shells want to be happy. So the innermost orbit wants to hold 2. The outermost orbit wants to hold 8. And the next orbit out would also want to hold 8. And again, it would hold 8. And now again, like I said in the video earlier, it's not really true. There's actually, when you take chemistry, you'll find that's not true. But for our purposes in our class, every shell except for the innermost holds 8. Okay, so if you have an atom that is not does not hold 8, you have the proton, neutron, and the nucleus, and you have, let's say, hydrogen. It would only have 1 electron. It has space for 1 down here. Or if you had, let's say, if you had helium, which is He, you have the nucleus, and then on the outermost orbit, which is the innermost orbit, it has 2, and it's a happy atom. If we were talking about carbon is atomic number 6. So there's going to be 2 in the innermost shell, and 6 minus 2 is 4, and that leaves 4 in the outermost shell. So every shell except the innermost shell holds 8, but that means there's also 2 spots here that it could be bonded with, or 4 spots, 4 spots that it could be bonded with. So again, from the inside, the innermost shell holds 2, and all the rest hold 8. Okay? So you need to remember that. 2 in the innermost shell, 8 on all the rest. Covalent bonds are where 2 or more atoms share electrons. So atoms share electrons. We're talking about a sharing situation. And you can see hydrogen usually has 1 electron. Carbon, on the outermost shell, has 4 electrons. And what we're doing here is we're taking those from the hydrogen. We're taking that hydrogen and putting it onto the carbon, and that hydrogen putting it on the carbon, this hydrogen putting it on the carbon, and this hydrogen putting it on the carbon. So the carbon now has 8 on the outermost ring. Well, hydrogen wants 2, so carbon is actually donating or sharing electrons with the hydrogen, and the hydrogen now thinks that it has 2 in its ring. So covalent bonds are sharing the sharing of electrons. And again, when you're looking at it, just kind of go over it one more time. You're looking at hydrogen has 2, this hydrogen has 2, this hydrogen has 2, and this hydrogen has 2, and this whole carbon has a total of 8, or it thinks it does. It's sharing them. And so it's a very strong bond. It's a very common bond, and it takes a lot of energy to break. But covalent bonds are dealing with 2 or more atoms that share electrons in order to fill that outermost ring with either 2, like in the case of hydrogen, or 8, like in the case of most other atoms. Another example would be carbon dioxide. Carbon dioxide is carbon with 2 oxygens, carbon dioxide. Carbon has 4 in their outermost ring. Oxygen has 6 in the outermost ring, so it needs 2. This is missing 4. This is missing 2. So when we put them together, we get carbon, and it would have 4 in the outermost ring, and we would pair it up with 2 oxygens, carbon dioxide, and we would pair it up with this oxygen and this oxygen. This one would have, well, it has 6, it's missing 2, 4, 5, 6, and then these 2 here. And this oxygen has 6, and it has 2 that it's sharing there. And then there's another 4 on the carbon. So what you see is that they're sharing these 2 and they're sharing those 2. And again, a very strong bond, but it's sharing the electrons based on the outermost electrons in the chain, in the rings. So carbon has a 4, bonds needs 4 more. Oxygen has 6, it needs 2 more, and so there's a sharing of electrons, very strong bond. Water is a great example. With water, you have hydrogen, which is only has 1, and oxygen, which has 6. This one needs 1 more. This one needs 2 more. Well, the oxygen is here. And if you think about it, it has 1, 2, 3, 4, 5, 6. And then hydrogen has 1. So it's those 2 are shared. And then another hydrogen are shared there. So this hydrogen now has 2. This hydrogen has 2. And oxygen now has 8 in the outermost ring. So again, hydrogen's happy because its outermost ring has full, which is 2, and oxygen's happy and its outermost ring is 8, which is full. So it stabilizes all the atoms involved by the sharing of bonds. Again, very strong, very common. Ionic bonds have to do with the donation of electrons. Here you can see sodium. This is sodium, and you can see the innermost ring has 2. The outermost ring has 8, but there's this one right up here that's all by itself, and it doesn't like that. It's unstable. It wants to get rid of this or bring in 8 more or get rid of this one. Okay, so it's not stable. I think it was not happy. Chlorine is again has 2 in the innermost ring. It has 8 on that next ring, and it has 7, 2, 4, 6, and this is the 7th one up here. The 7th one here, and so it either wants to bring 1 in or get rid of 7 of them. Well, it's easier to bring 1 in, just like on sodium, it's easier to get rid of this one. So if sodium gets rid of 1, it becomes positive because electrons are negative. So if you take away a positive, you become take away a negative, you become positive. Likewise, on chlorine, we're going to bring in the electron from sodium. If we're bringing in a negative, chlorine becomes negative. Well, if you add a positive and a negative, the opposites attract, kind of like magnetic net north and south pole. So what we end up with is this right here. We end up with this one being donated over to here, so you have the 8 on the outside here. You have, because this one's no longer there, you have 8 on the outside there. This becomes positive, this becomes negative, and they're attracted to each other. It's called an ionic bond. It can be broken fairly easily with polar bonds, which we're about to talk about, like dissolved in water. And this right here, by the way, is soap. This is sodium chlorides. And this is table salt. Sodium. Sorry about that. Sodium chloride. Sodium chloride. So what we have here is this electron is donated over to this atom, and so we have 8 on this one, and we now have 8 on the innermost this one because this one has been lost. So this atom is stable, the sodium atom is stable, the chlorine atom is stable, but they've changed charges. This one has become positive, this one's become negative, and there's an attraction of positive to negative. So basically, ionic bonds are weak, and they can be broken by like dissolving of water, polar bonds of water. And so basically, ionic bonds are the attraction of oppositely charged atoms, a plus and a minus, caused by ions, the loss or gain of an electron. The last kind of bond is a hydrogen bond, which is most commonly found in water. That's the one you need to know for this class. You can see a covalent bond is formed here in water. Here's H2O, 2 H's, 2 hydrogens, 1 oxygen. But there's a bond between the molecules that is formed, and it's a hydrogen bond. It's basically a bond of the charges of the parts of the atom. You can see where because most of the electrons have gone from the hydrogen to the oxygen, it becomes negative. Negative electrons are negative, and they kind of are more at the oxygen end, filling in that area, that bond. So that's the negative part. That means that the hydrogen part, because the electrons have traveled this way and are more over here, this makes this area very positive. And again, the positives attract, the negative and positive opposites attract, and it's a bond that causes the water molecules to align a certain way. And so, what happens is in molecules when they are, think of like ice, it crystallizes, and it's because all those molecules line up in a certain particular way based on that hydrogen bond polarity. So those are the 3 kinds of bonds. You have a covalent bond, you have a ionic bond, and you have hydrogen bonds. Again, covalent bonds are very strong. There's sharing of electrons. Ionic bonds are weaker. They can be taken apart by polar molecules such as water. And a hydrogen bond is the bond that connects water molecules to each other or attracts them to each other. So it gives water its cohesion and cohesion forces, which we'll talk about in a future video. Again, if you have any questions, please make sure you ask me in class. Study your study guide. I hope you're studying for the tests. Good luck.